So 6.1, we are going to study a very spatial distribution, normal distribution. Sometimes they also call like a Gaussian distribution, G-A-U-S-S, Gaussian distribution. So why do we study this one here, like in the beginning, right? This one turns out to be the most popular distribution we are studying, right? For most data scientists, for most statistics job we are doing, right? We are doing in terms of this spatial distribution we call normal distribution. You can see the name itself, right? Normal distribution, nothing special. Is that right? So give you an example in this word here. So many distribution, they follow normal distribution. For example, if we plot, right, like for our class, the height of each person, right? We measure the height of each of us, right? And then we see like, I plot them using this histogram, right? I check like how many people got like 6.5 something, and how many people got 6.6, and then 6.7, 6.8, and so on, right? So I plot them using a histogram here, and then at the end, usually most of the time when we see this histogram here, when we try to connect them using a smooth curve, usually you will see some like a bear-shaped form. Everybody? So that's the beauty of this distribution here, right? So usually you will get a bear-shaped form. I mean, it's not exactly the bear shape. When you are getting more and more sample, more and more data, the curve will be more and more close to this bear-shaped form. Okay. So that's one example. If we measure like number of height, right? Similarly, like how much for the weight of each us, right? Similarly, if we plot that, very most likely will be a normal distribution. A lot of cases, right, in this universe. Everybody. So for this normal distribution, I would say it's like more than 95% of time. You see those data sequence here, right? They follow this normal distribution as long as you have big enough data. Like for example, if you only have like 5 data points, right, it's going to be very difficult. I think about that way, right? Like for example, usually like more than 30, more than 50, more than 100. I mean, those big enough, the bigger the data you have, the curve will be more close to this smooth bear-shaped form. Okay, so for the normal distribution, once you know the curve, you can see they have to satisfy those attributes here. Okay, so we have like 6 conditions. Okay, number 1, everybody, mean, median, mode, they all at the center. So what does that mean? That means you can see, I mean, from that picture here, is right? The mean, that's the average, right? Median, if you remember, median is what? It's like you sort the data from low to high or high to low, the middle point, is right? Mode, that's the one happening most often. So in that case, for the normal distribution, they should be all the same. They should be all at the center. Okay. Number 2, unimode, right? I think we had some questions, right, from the previous exam. Is that the mode always unique? Not always. Is that right, everybody? Sometimes it's unique, sometimes it's not. But for the normal distribution, it is a unique case here, right? We are not going to study those bi-mode or tri-mode case. Remember, like those waved form, right? If you see those waved form, right? Like that, right? So like you may see like several data points happening the same, like pretty often in that case, right? So we are not going to study those cases. So we will study only this, the unimode. Is that clear? Now let me erase this. Number 3, we have symmetric. Everybody? So in other words, if you know one side of the curve, right? You can easily draw the other side of the curve, symmetric. All right. Number 4 is continuous, right? It's continuous. I didn't draw the curve here, right? It's continuous. There should be not any like hole, right, in our curve, or there should be no such like a jump, like from here to here, all of a sudden jump. Like if I, oh, sorry, let me see, let me try to, if I can use that here, and then all of a sudden like that. And then you have like just jump, right? No, we don't want to study those cases, okay? The normal distribution has to be continuous. There shouldn't be any hole, there shouldn't be any jump, okay? So in other words, it is a smooth curve. Now, I'll try to answer the questions later, okay? Number 4, continuous. There should be no gap, no hole here. Number 5, never touch x-axis. All right, what does that mean? That means you see that curve here, right? So ideally, you will see this curve here like going down, going down, going down. But that one, we are getting close as possible to this horizontal x-axis here, okay? As close as possible, right? But never touch. Like you can get very, very close, but never touch. Okay, that's the key idea here. Number 6, all the area under the curve is equal to 1. So what does that mean? All the area under this curve, right? All the area under this curve should be equal to 100%. Remember, in the chapter 5, right? We studied the probability distribution for the discrete case, right? We have one of the conditions is what? When we add all the probability together, should be equal to 1. Should be exactly equal to 100%, right? Because this case here is a continuous case. So in other words, when we add all the possibility together under this curve, it should be also equal to 100%. That should be equal to 1. Okay, so that's the same as the discrete case here. Now, those are the 6 important attributes to satisfy for this normal distribution. Those very important 6.
Professor?
Go ahead.
I have a question, please, about the normal Bell graph. So if it's supposed to be equal to 100%, and I guess the area is supposed to be 100%, what about points on the graph? Aren't they different from a percentage?
So the one thing that here, if you study this example here, right? So we have, for example, 5.7, say we have like 20%. All right, let me write down that here. For example, okay, like 20% of people, they have with this height, 5.7, is that right?
Mm-hmm.
Now, that is like, for example, that probability here, like 1 histogram. You see what I mean?
Mm-hmm.
And then when we add all those probability, for example, like 5.8, what's the probability for those people, right? The percentage.
20.
So in other words, when we add all those percentage together, should be equal to 100%.
Mm-hmm.
Follow me?
Mm-hmm.
That's the idea. When we say all the probability under this curve should be equal to 100%.
Mm-hmm.
Yeah.
When they're added together.
Yes.
Okay.
Yeah. So here we are talking about this concept here, right? Area. You probably heard about that, right? Area, right? If it's a rectangle, you have the y's, you have the, like for example, you have A, that's the y's, B, that's the height. What's the formula for the area?
Base times height?
Yeah, that's right. A multiplied by B, right?
Yes, sir.
Okay. Now, the question is, what if B is 0? What's happening here? Or A is 0, one of them. For example, if A is 0, that means the base is 0. Then this rectangle becomes what?
flat, I
becomes
think.
one line.
Oh, one line. Okay.
Is that right? Because
Yes.
if A becomes 0, that's like a shrink. So becomes one line. What's the area of one line?
Flat. There's no area maybe, or it's just
That's
flat.
right. There's no area.
Okay.
There's no area. Or you can consider A is equal to 0, right?
Mm-hmm.
So in that case, 0 multiplied by anything is 0. So that's the reason we say if it's just one line, the area is 0. In other words, the probability is 0. You see what I mean?
Mm-hmm.
Okay. So that's the reason we say here is really what is a whole area. We don't talk about one line. Follow me?
Mm-hmm.
We don't talk about one line. We need to get like some small, even it's like a very small rectangle, you need to have that. That's the key part here.
So there's a relation between area and probability. They're co-connected.
Yeah, you can understand that way. Yeah, but I don't want to get confused with the probability here because that will involve more advanced statistics. If you study more, then we are talking about the PDF, CDF, all different stuff. But right now, I don't want to introduce this one here. You will get way more confusing.
Mm-hmm.
Okay.
Thank you. Thank you, Professor.
Now, let's continue here. Second part here, because we have so many bell-shaped form, right? We have, for example, the weight of each of us, we put them together, that is a normal distribution. The height of each of us, right? We plug them, it is follow a normal distribution. They are all different data sequence. They are all talking about different stuff, right? So you see, I brought a few examples here, like those different bell-shaped form. They may have the same center mu here, right? But it also could be like bell-shaped from here, right? Any of those, right? The question is, can we have something that is standard? Standard means like we have some reference point. Why we want to have this standard? Because that can help us doing the calculation later. We will have more details for that. So this section here is to help us. We can always transform any normal bell-shaped form, right? Any normal bell distribution to this standard, everybody, standard normal distribution. Always, we can do that by the formula. That's what we call z-score, z transformation, right? So transform to any normal distribution to this standard normal distribution has to satisfy two conditions, everybody. Those two conditions here, okay? Number one, to be standard, you can only have the center at 0. Is that clear? So you cannot have any other center. For example, 5, 7, like our previous example, like in terms of the height, right? For if that's our center, 5, 7, right? That's not the standard. That is a normal one, right? As long as it's a bell-shaped form, everybody, it is a normal one, but it's not a standard. To be standard, number one, center at 0. So you cannot move this curve to the left, to the right. No, you cannot move that. You have to fix here. Center is right here. Follow me? Number two, the variance has to be exactly equal to 1. So what does that mean? The variance usually is to help us control the curve is going up or going down. So in other words, previously, when we say the center has to be exactly equal to 0, it's like right here, right? We cannot move to the left, not move to the right. That control the horizontal direction. Variance equal to 1 control the vertical. So we cannot like pull this curve up or push this curve down. No, we cannot do that. Has to be only one curve here. Follow me? So that's what we call standard normal distribution. Okay, so the next question is, why do we want to study this standard normal distribution, right? Our goal here is to help us calculate. Remember, the goal for this class, right? If we can calculate a lot of probability questions, right? That will be help us understand this word much better. So in other words, this standard normal distribution can help us calculate probability much faster using this standard normal distribution. Okay, so if it's not using that one, if it's based on any normal distribution, and I'm asking to calculate that probability, if we are not using this standard, it will be much more difficult. Okay, so we will come for more details for that. Okay, we will give you more examples. How do we use this z-score transformation? Right now, it's kind of a confusing, right? So later on, we will have more examples. Any questions before we continue? So that's this part here. The next part I want to introduce.
I do have one question, actually. So for the z-score formula, what is the thing on the denominator? What is
denominator is the variance, the sigma.
Variance, thanks.
Yeah, variance of sigma. Remember, the normal distribution, sigma, this one here, right? This one, if we're starting from the left-hand side, right? Sigma square could be anything, right? Could be anything, 2, 5, any number, as long as positive, right? Then when you normalize, the sigma square in this case here, right, has to be only equal to 1 for this case. Okay, so in other words, the one thing I didn't mention earlier, this z is reserved for what? For standard normal distribution. So in other words, whenever you see any letter like in a context, right? Context. So they are talking about z. That means remind you, oh, they are talking about the standard normal distribution, right? For the any other normal distribution, which letter we are using? Usually we are using x. Z is reserved for standard normal distribution. Is that clear? That helps answer the question?
Yes, thank you.
Professor, z doesn't have to equal to variance, correct?
Z doesn't have to be equal to variance, right? Yeah, Z is from the calculation. Z is the one that coming from we will have an example here to explain how do we calculate Z. Right now, it's only one formula. You may get confused. Later on, we will have like example coming back here many times. You will love this, I'm pretty sure. Okay. Any other questions? This part here we want to is going to be very important. Why? Because this part we want to use the standard normal distribution table to help us calculate probability question. Okay, so which table I'm talking about? I'm talking about this table. Everybody, I'm going to upload this table, but you will see this table here. You see that here is called standard normal cumulative probability table, right? If that confuses you, you simply consider this is what? Z table, right? If that's easier, okay? So what's that Z table to tell you, right? How do we use this Z table? That's going to be one of the big focus for today. Everybody, it's going to be very important, okay? This Z table here, there are 2 pages. There are 2 pages. You see this page here, right? And there's another page, okay? So how do we going to use this table? I want you to have something that you never forget, right? You started from the center. Everybody, the center. All those numbers in the center, right? Those numbers in the center. And then similarly, the second page, right? All those numbers in the center. Remember, what are those? Those are probability. Okay, so those are the things you don't want to get confused. Okay, whenever you see that table, Z table, or the center, they are talking about probability. That's number 1. Number 2, so you may wonder, well, this corresponding like a probability corresponding to? Is that right? What's the corresponding match? So that's one of the key parts we want to understand. Everybody, we can use this example here. This example we are having here, this one here, right? So this question here, we want to find out, everybody, the area to the left of negative 1.96, negative 1.96. Everybody? So we are trying to find out the highlight area, if you can see that here, right? To the left. Okay? So, and this curve here is coming from the standard normal distribution. And then our goal here is try to find out what's the probability for this highlight area. Everybody, is that clear? That's our question here, right? So how do we find out that? We have to use this table. This table, we are trying to show that here, okay? Now, it's going to be very, very important, everybody, if you care about this class, right? Remember, our class is like a step-by-step. In the first few classes, consider as a foundation. If you get lost tonight, especially tonight for this lecture here, it's going to be very, very difficult for you to continue. Everybody, pay extra attention for the next few minutes. How do we find out this highlight area here? Okay, so we are going to check this table here. We have negative 1.96. Is that right? This on the curve here, negative 1.96. Now, we mentioned previously the center is the probability, right? The center is the probability. In other words, this negative thing is never probability. Is that right? Is that like Z? Remember, this is our Z, right? This is a Z, right? This is a Z curve, right? So where do we find out this negative 1.96? Everybody, focus on this column here. Follow me, right? The left column, that's the Z. Now we are looking for negative 1.6, 1.96, is right? We have this negative 1.9, is right? Everybody, very important. Now where do we get this 0.6 something, is right? Zero, like negative 1.96, how do we get that 6? We only have negative 1.9 here, okay? This is the tricky part. So how do we get that 6? We can read this, everybody. Negative 1.9, this column here is for 0, okay? So negative 1.91, follow me? Negative 1.92, because there's a 2 here. Negative 1.9, similarly, right? Where's the 6? 6 is corresponding to here. Everybody? In other words, the second digits, 6, is where? Is this one here. Follow me? Those are the second digits. Okay? So now we are trying to get negative 1.96 corresponding to this number here. Follow me? Right? So negative 1.9, that'll give me this column. Right? Some number, we are going to choose one number from this row, sorry, right? This row here, right? And then the second part, out of those numbers, which column we should choose, depending on the 6, right? The second digits, because we have a 6 here, 0, 0.06, right? So that match this column here, give us the probability, everybody, 0.025. So in human language, that's 2.5%. What does that mean? That means this area, the highlight area here, it should be equal to what? 2.5%. So that's the reason you see I have, everybody, 0.025. Follow me? It's very, very important. You see that one, I highlight that for you. That is one of the example here. Everybody? If you can, I'm going to upload that Z table in the canvas so you can see that you can use that to get those probability. Okay, that's the first example, right? We got this 0.025. Any questions for this part here? Now, we are going to have two more examples to help you understand how do we use that table, okay? Let's see. Second example here. Help us find out the probability. Okay, I'm ... That means I copy everything as the first example, okay? So find out the area to the left of 2.06. Everybody, if you have the table, let me open that, right? So we are trying to, oh, sorry. Oh, erase. Yeah, so we are trying to find out where is the corresponding probability to the left, everybody, to the left of 2.06, right? Remember, we are looking for 2.06. Okay, on the first page is always negative, no good, right? So we have to go to the next page here, 2.0. Remember, we are looking for 2.06, 2.0, that's this row here, right? And where's 6? Everybody? 2.06, that's this one here, corresponding to the 0.6 here. Follow me? That's very, very important. Very, very important, okay? So we can find out the corresponding probability to the left is what? 98.03%. That's the corresponding probability we are looking for. So we can answer that question here right now is what? The corresponding probability to the left of 2.06 is what? 98.03%. Everybody, this table here, you may realize, right? It's always to the left. That's the one thing I want to point out, right? For example, this Z is what? Like 2.06, 2.06, 2.06, right? Sorry, I'm trying to write down this, but this space is running out. Okay, 2.06, right? So this is our Z here. So this order probability here tells you, starting from this point, everything to the left. Is that clear? So all those probability, right? This page and the previous page, always to the left. Always, everybody, always to the left. So far, we have two examples, right? Both examples, we are asking the probability to the left of some number. This case here, right, 2.06, that is like this number here we find out, right? That's everything to the left, right? Previous example, we have like negative 1.96, if you remember, right? That's negative 1.96, right? And that'll give us like here, starting from here, let me erase that so you don't get confused, okay? So previous example, we have 1.96, is that right? We
Yes,
asked,
sir.
yeah.
So why is it always to the left shaded area?
Yeah, because the table here trying to simplify the case. If they have multiple cases together, you will easily get confused. So the table probability here always give you the probability to the left. Now you may have the question, what if I want to calculate the probability to the right? Is that right? How can we calculate that? So we will have those examples coming. Okay.
So you just subtract it from 1?
That's right. That's right. So we will have more examples coming. Okay. I'm excited that you know that already. Okay. So that's for this case here. I want you to understand. Always, this table here is always the probability to the left. Okay. Now let's see. We have like this third example coming. Right. Let's see. How do we find out that probability? The third one and fourth one. You know what? We can cover the number 4 first, right? Since we are talking about to the right. Everybody? We are asking they find out the area to the right of 1.65. So what I mean, if I draw the bell-shaped form, right? Bell-shaped curve, right? They're asking 1.65, right? And is what? Is to the right, everybody? It's like this area. That's the one they're asking, right? So help me find out what's the probability for that area, right? So now, if we are trying to find out directly from the curve, right, 1.65, let's see. We can see that is 1.6. Where's 1.65? That's this one here. Follow me, everybody. Where's the 5 coming from? 1.65. You see that 5 here? The second digits, okay? So that means we corresponding match. You see, you started from this row, right? Sorry, this row here, and then corresponding to this column, 9505. So that tells you the probability to the left, everybody, is what? 9505. Now I'm asking, how do we find out the probability to the right? I mean, to the left, to the right, this area. So as someone just mentioned, right? We can just use 1 minus 0.9505 to get the corresponding probability. Is that okay? So they should be equal to 0.495, something like that. Okay. So let me see. You see that one here, 0.0495. Is that clear, everybody? So the table is always giving us the probability to the left, right? But if we are asking the question, probability to the right, we can also do that. Is that clear? Now, there's one more case I want you to understand here is, how about if they're asking the probability in the middle, right? Then we are in trouble, is that right? Probability in the middle, in this case here. How do we find out that corresponding probability, right? So this example number 3 here, they have 2 data points, negative 1.37 and positive 1.68, right? So the question is, can you help us those probability in the middle? That's the one, right? So we have to cover the 2 cases. Probability to the left, that's easy, right? We can just read that directly from the curve, from the table, Z table. Probability to the right, 1 minus, right? Now, how about in the middle? So let's be careful. How do we get the probability in the middle? First, let's use the table directly. Let's see if we use the negative, 1.68, right, from the table directly. This table here, right, 1.68. Let me see. Let me rest that one here. And so 1.68, where is that? 1.68 should be, everybody, be very careful. 1.68, where's 8? Let me see, 1.68, that's like this column here, is right? Let me try to redraw that, okay? So 1.6, this column, this row here, right? And then 8, where's the 8? 8 is this one, 8, follow me? So we are going down this one here, 1.6, that's this number here, follow me? This number, you see, corresponding here, this row, this column, intersection, 9535. Everybody? That's the probability to the left of 1.68. What does that mean? In this picture here, that's 1.68, you're starting from here, right? You have everything to the left, everybody. All those probability here to the left. Like based on this curve here, right? I think I don't want you to get it confused. Like, I mean, those one outside, right? It's like starting everything 1.68, right? And then going to the left. It's like this, like that. Everything to the left. Follow me? Right? So that's 9535. Okay? That's more than what we're asking, is that right? Remember, we only ask those part in the middle. Is that right? We don't need this piece, is that right? So we have to subtract this piece. Everybody, how do we subtract this piece? This piece here is coming from this number, negative 1.37. Remember, this table here always give us the probability to the left. Is that right? So negative 1.37, if we check the table, That will give us the negative 1.37. Let's see, where is that? Everybody be careful here, focus, okay? It's going to be very important, right? Negative 1.3, this column here, follow me, right? 7, where's the 7? 7 should be this one, right? My bad, I should, yeah. Negative 1.3, let me erase that, you don't get confused. Okay, let's try to redraw that. Negative 1.3, this column here, right? 7, where is the 7 coming from? 7 is coming from here, follow me, right? So where's the intersection? Intersection, this number here. So in other words, this probability here, right, is what? Is equal to 0.08, right? So 0.853. That's this probability.
It's 0.0853.
Thank you. Yes, 0.08. So it's about 8.53%, right? Using human language. Okay. So we are going to use those two numbers to subtract. Remember, everything to the left is what? Is like the 9535. Remember, that's the number we got, right? This one here, 9535, that's what? That's everything starting from here to the left. Everything, 9535. Now we subtract this area here, right? Which is 8.53%, give you the probability in the middle. Follow me? Right? That's 86.82%. That's the probability we are looking for. Everybody, tonight class is very, very important, right? If you get lost here, it's going to be very difficult for you to continue this class. Okay, so make sure you understand those three situations. When we ask the probability to the left, right, what do? Read the table directly, right? Because that's what's given. Always probability to the left, right? And then probability to the right, 1 minus that, okay? And then probability in the middle. So you are going to use two numbers, the corresponding probability, and minus that. Any questions?
Professor,
Yeah.
can you repeat the one for the left?
The one that is the left is the directly coming from a table.
Okay, directly from the table. Okay, thank you.
So for example, 1.65. If I'm asking the probability to the left of 1.65, what do? You're looking at this table directly, right? So 1.65, where's that? 1.6, let's check out 1.6, 1.6, right? 5 corresponding to here, this 5, remember? Is that right? So that is corresponding to this number here. That's 9505. That's the reason I write down 9505 here. Follow me?
So for the middle, could what I said in chat work? You calculate the left side of the left one and the right side of the right one, add them together, and then subtract the total from one?
That's also okay. Yes. Yeah. I'm trying to see which way is easier, right? So it's up to you. I think if you use two number here to subtract, might be relatively easy. Is that right? So, I mean, it's up to you which one you feel comfortable. Okay. Now let's see. That's the most important thing, everybody. Tomorrow, sometime tomorrow after class tonight, right? Try to spend some time going over those three examples here. Everybody, it's going to be very, very important. Okay. If you get lost here, you cannot continue for this class. Okay. So for this note here, if you got confused, it's totally fine. Okay. The idea, what we are trying to say here is, remember earlier we tried to say the probability of one line is equal to 0. Is that right? Remember we explained that. If you got confused, that's okay. That's not really the focus. The focus is you want to understand how do you calculate the probability based on the t-table.